Thank you. Uh, I don't know if it's morning or yeah, it's fine. My name is Mr T Sekgobela. I'm from UNISA, from the Department of Mathematical Sciences. Uh, Today we'll be engaging with grade 11 learners. We'll be doing analytical geometry. So that's the topic we're going to focus on. And in one always says that when you look at mathematics, it's a bunch of different types of maths that we do. So with analytical geometry, what is known is that we are dealing with coordinates geometry. When one says what is that, so we are saying in coordinates geometry, we are combining what the geometry and the algebra. So we have the geometry and the algebra to solve what different types of problems. In saying that, we are going to cover these topics or these sections. The first one will be the inclination of a line, where we are going to find the gradient and the inclination of a straight line. What do we mean by that? We will see as we go further what does that mean. Then the second one will be the equation of a straight line. I always say from grade 10, you might have done some of this, where you've done the equation of a straight line using the gradient and 1 point given, which is the y-intercept, and then using the gradient and 1 point, and then using 2 points, using what? A parallel or a perpendicular line. So we'll explain that further as we go on. So the first part is the question says, what is the inclination? The gradient m of a line is its slope or steepness. So we can have different types of lines, or we can have this line here. If we have this line, we know that this line is gradient will be positive. And then if we have a line like this, we know that the gradient of this will be negative. So in case of that, that's when it explains what the steepness or of that slope. So now, when you look at this, we are explaining two things here for dealing with inclination of a line. Then the gradient of a line should be known. Then you can be able to use what? That gradient to find what? The inclination, which is the theta. And then they're saying is the angle formed between the line and the positive x-axis measured anti-clockwise. We know that when you are measuring something anti-clockwise, if we have something like this, then we have a line. So we are going to measure our angle here, and then this is the straight line that we have. We have something like this. This is the equation of the straight line. So now we're saying this theta that is created in between the two, that is what is the angle that is formed. So the only way we can find that, we're saying we're moving anti-clockwise, because the clockwise means that you're going to move from here, going that side. Now we're saying by using that, we'll be able to find what? The theta. And then we'll see in the next slide. Now they're saying the angle of inclination is always in the range. So bear in mind that you must always remember that. And then if we look at that, they are saying the angle of inclination is what? Is the theta. I think somewhere we're going to show that this is equals to m, which is our gradient, and then we have tan theta, meaning that our theta, which is the inclination, will be the tan of that inverse of the m, where the m is the gradient. So meaning that if we know the gradient of this line, which is given here in this point, now we can be able to find what? The inclination line. Now we recap some of the basics you learned in grade 10. The first is the distance between 2 points. If we say the distance between 2 points, we always use this formula. the formula is always easy to use. You normally just have to know how to simplify going further. Now, if we're saying the midpoint, in the midpoint we have 2 points. If you have 2 points, which is A and B, now the midpoint will be the point that is in the middle. And then to be able to do that, we use this formula here, where x plus 1, x plus x1 plus x2 will be divided by 2, and then we're going to have 1 y1 plus y2 over 2. So that gives you what? The point that is in the middle, which is the midpoint. And then the gradient, which you have seen most of the time, we're saying it controls the slope. It tells you how the graph behaves. If it's positive, you'll see the graph behaves in this manner, in this good part. Then those are some of the things that you must always remember. But you must always remember that the gradient is the important part in our graphs. Now we're saying to find that gradient, we're just saying the gradient is the y2 minus the y1 over the x2 minus the x1. So the 2 points that are given, this point and this point, then from there you will get what? The gradient of this line. So these are some of the things you have done before. Now we're saying, remember I've mentioned what? That, which is they say now is the relation between what? The gradient and the inclination. So now these are some of the most important things that you always need to remember. We are saying the acute angle, which is 0 to 90 degrees. So in that region, or in that quadrant, the theta will always be positive. Now what happens if you move out of that? Then you go to in between, in the second quadrant. Now you have this part. We are saying here the theta will be negative. If the theta is negative, what is going to happen? It doesn't become the theta, but it becomes your reference angle. Now we are going to say you are going to get the reference angle, which you take your reference angle, you are saying 180 plus the negative angle that you get. You'll see that if you do some exercises and then it become much clear. Now we have something there, which is one of the first example. Now we're saying, why are we leaving that negative here when you come in? We're saying always when you are punching on your line, leave the negative out, because the negative says what? That is gonna fall in the second quadrant. Now we're saying if you leave the angle, that becomes your reference angle. Hence it becomes your reference angle. You are going to subtract. Why are we not using plus? It's because we don't want to fall out of that region. If you use plus, we fall here. That's why we use what? We leave the negative, then you're going to subtract the 180, which is saying in this region now. You want to get in this region. Your angle must be positive, because we said we are calculating from anti-clockwise, moving from here, going all the way somewhere. That becomes your angle. Now in the second example, they are saying they find the inclination of line, where you are given 2 points. If you are given 2 points here, this point and that point, you can find what? You can find the gradient. By finding the gradient, you can say this is x1, and then this is x2, sorry, y1, and then this is y2, x2, and then y2. So we have these points. In this case now, we can see that if this is y1, y2 minus y1, anyhow you do it, as long as you don't mix the two, the answer will still be the same. And then we have x2 minus x1. So in our case, we can have the opposite the other way around, which becomes xy2 is 3, which is fine, minus y1, that is the case. And then we have this. You can either do it the other way around or this way. The answer will still be the same. Now, after finding our gradient, now we can find what? The theta. Finding that theta, we can just go through and then you leave the negative, remember that. In that case, approximately 18. Something is missing here. We can look at this point. If you draw a Cartesian plane, where will this be? To be somewhere in between, I think, because we're gonna have we're gonna have somewhere, it's gonna be x and 9, and then we're gonna have the positive here. So meaning the angle will be in between there. You can either move it to, because I think now we need to know that angle, which is in between. Because we are saying our angle, well, we can move it to here, up to there. That's still okay, then everything. So what we are saying now is, in this case, we are going to have 180 degrees minus what? 18.43. And then that gives you that angle that is here. Because of how big it is, it would be a large angle in between the two. Now, we go to the parallel or the perpendicular lines. What are we saying about if two lines are parallel? We know that we're saying that they have the same gradient, meaning that the gradient of the line on this side and the line on the other side will be the same, meaning that they will be equal to each other. They also have what? The same angle of inclination. So you must always remember that. And then for perpendicular lines, we're saying the product of their gradients is always equals to -1. If line 1 is perpendicular to line 2, then we have this. We're saying that the gradient M1 and the gradient M2 will be equals to -1. This means one gradient is the negative reciprocal of the other one. By just using that, you take one to the other side, that's the case. You can either take M1 or M2, that's what it means. Now, remember I mentioned that we'll come back to the line. The equation of a straight line. The equation of a straight line is given by this formula. And then they say there are 4 scenarios there. If there are 4 scenarios, the first one we're saying, if you know the gradient, and then you know one or the y-intercept, meaning you know that what is c, you can be able to find what? That equation. The second one we're saying, if we know the gradient and one point, which is x1 and x2, now you can substitute the two to get what? To get your c, which is your y-intercept. Always the case, but yeah. So now we're saying if you are given 2 points, given 2 points, you can find what? You can find the gradient using what? The formula. And then given a point at a line that is perpendicular or parallel to it. So remember we said if you know that, if you are given a point and a line that is parallel or perpendicular, you can find the gradient, or you can use the equation of the straight line to solve that in this form. You have a point and a line that is parallel or perpendicular. We said what? If that is the case, you will find that the equation of the line that is here is given, or the equation of the line that is here is given, meaning that you have what? Your gradient is given. You can just use what? If they are parallel, it means what? The gradient will be equal to the gradient 2. But if it's perpendicular, then that will be m1 by m2 is equal to -1. So because you know the gradient of that line, you can find the gradient of this line that you are looking for using that. So now they are saying if you are given a gradient in this form, and then you have y-intercept, now they're saying you are going to directly substitute m and c into the standard form, which becomes very easy. because you already have what is M, you already have what is C. So that becomes this equation. Now, if you are given a gradient and 1 point, what we are saying is, by given a gradient and 1 point, you are going to use this formula, which is the slope. Then we're saying substitute the gradient M, and then the coordinates of the point, which is this point. You can substitute that point and then that. So now it will lead to that equation of y is equals to mx plus c. So that happens when you are given that. Now calculating the gradient, we can use that. So now they're saying given 2 points, x1 and x that. Then we can calculate the gradient and using what the formula that is given, and then use the gradient and one of the points, which is just basically the previous slide we have done, which is just substitute that y and that x1, y1 and x1, then it is. So now we're saying this is one of the example. They're saying find the equation from 2 points. If you have 2 points, you first find what the gradient. After finding the gradient, you can use this formula. Then it gives you, just do some math there. Now, using parallel and perpendicular. Now they are saying parallel to y. So this is the equation. The new line has the same gradient. That's what I mentioned, that if you have, they give you a line, and then they say this line is parallel to this line. They give you this line, and then they're saying it's equals to this equation. Now you have another line that is parallel. Now you don't know what is this one. It says line 1 by 1. You don't know what is. What we are saying is now, because we know that the gradient of 2 parallel lines, they are equal. We're just saying the gradient will be that. Hence, you know one of the point that is in this line, you use it to find what the equation of that line. So that's basically what. Even if it's perpendicular, you apply the same technique. In doing that, so now we're saying there are some special lines in triangles. Then they're saying analytical geometry is often used to find the properties and equations of special lines within triangles. The first one is median, the altitude, the perpendicular bisector. Now they're saying we can find the equations of these lines using what? The methods we just learned. Now, from those methods that we just learned, what are we saying? The first we're saying for the median of a triangle, they want us to find a line segment. They say now the definition of that, we're saying is a line segment joining a vertex to the midpoint of the opposite side. It bisects the area of the triangle. What does this mean? It means that if you have a point A here, which goes there, and then you have another point here, which is B, and then you have another point, which is C. What we are saying is, if we choose our A to be a vertex, now we're saying we are going to have a line that bisects the two in the middle, or it becomes the midpoint of the opposite side. The opposite side are these two sides because of that vertex. The opposite of that is this. So now we're saying if that is the case, now you have 2 points, the vertex A and the midpoint, which is M. That is our midpoint. By now, we are saying, how do we solve this? It's very easy because now we know this. We know this. We know how to find the midpoint. We have seen how to find the midpoint of point B and C. It will be the x1 plus x2 over 2, and then y1 plus y2 over 2. So by doing this, you will find that midpoint that is in between the two. After finding that, now you can say, because you know what is the equation of that, because now we say if the two, now we can use what this point and this point, because we know the midpoint, which will just be x plus c. Now we know that we know our gradient. Hence, we know our gradient. We can take this point, which is our vertex, and substitute here and here, and then we get what? Get what is c. That gives the equation of that median on the triangle. And The other one we're saying is the perpendicular bisector, a line that passes through the midpoint of a side and is perpendicular to that side. It does not necessarily pass through what? Through the vertex. So then they say find the coordinates of the midpoint M of side BC, and then calculate the gradient of side BC. The perpendicular bisector has a gradient M, which is equal to that. Using the gradient and the coordinates of the midpoint M to find the equation. So if we have something like that, we can have this. So that can be the line we draw in between, which does not have to, hence they're saying we don't have to, it does not have to pass through the vertex. That's what it means. But it bisects what? The two lines. And then in the summary, I think, yeah. Then today we learn how to relate what? The gradient. So this is what we have summarized by doing all of this. We have learned how to relate the gradient and the inclination theta using what? The M is equals to tan theta. Use properties of parallel and perpendicular. Find the equation of a straight line given. It can be any information that is given there. Define and find the equations of the median, the altitude, and the perpendicular bisects of a triangle. So there are some exercises I think is in the grade 11 textbook that you can go through and see, and then we can discuss those exercises when we are going to engage. I think that is all for the lesson as it goes. I have some examples that I have tried to go through, but then I said I will just keep them. Then I can ask you guys to go and do the exercises in the textbook. From there, we can engage when we are going to have a session. I think that's fine. Thank you.